Hey there everyone, welcome to the series Connecting Ansys and SQL the Ironpython way. In previous video we have seen why we need to connect Ansys and SQL and what was the purpose of it. In this video we will see data modeling. So I will just continue from our previous video. In previous video we have created some of the material model. So for the example geometry, result, material. So we will see how we can conceptualize this into a physical table, or let's say a concept. Let me just open up a new whiteboard. So in this new board I will just paste the all this which we have covered in the previous video. So you will see that we had geometry, material, mesh, users, and other tables. So there are a couple of ways data modeling can be done. So initially it starts with a concept. After you conceptualize, you have to physically create these models in any RDBMS system. Once you have this, we can do insert and update operations. So these are nothing but data manipulation language, DML operations. In conceptualization, we will see how we can convert this idea, whatever we had, like geometry, material, then users, results, all this. There are two ways to do that. First approach is, let's say you are creating one single table for everything. So you are creating just one table. So in that, what will happen? You will have couple of columns. First column will be ID. Then you will have dimension A, and then you will have dimension B. Then we had materials table. In that, let's take material name first, material name, and then we have material poisons, mat. Let's name it as mat poisons. Then we have mat material elasticity. Let me write as mat elast, and then we had mat density. So I will just write as mat dense. And then we had what else? We had this user table. So let's have it like username. Let me just move it a bit. So we have user name. Then after that we had the results table. Within results table, let's name it result A. It can be anything. Then result B, and finally for all these values, let us have ID S1. So first row you will do an insert with that. Maybe in ID1 we will insert a value. Let's say you are using material A, mat A as the name, and you will do analysis. Then again mat A being used in some other analysis. Then you will do keep on inserting these rows one by one. But in future, let's say you are having any changes, for example mat A name you want to change. So let's say you are having 10,000 analysis being done, you have to change all the names one by one. Let's say you have lost anything, you will have data inconsistency. Suppose some user has left and you want to change the name, so that will have all the inconsistent. Or maybe you are adding some column unit. So in unit you are making some changes, some values within dimension or anything. You have to change all those one by one. So this becomes data redundant. That's why we had one more method which is called as data normalization. In this data normalization, we will break this entire table into small tables. So we have couple of data normalization like 1NF, 2NF, 3NF. Basically it's used 3NF. Let's start with geometry. In geometry I will have the basic ID column, and then in dimension A I will write dim A, and then dim B. Similarly next will be materials table. In that I will have mat name, and then after material name I will have material um, Poisson's ratio, then material elasticity, and then material density. Then for next is users table. In users table I will have ID, and then I will have name, and then finally let me add ID for material as well, and then I will have result table. This result table actually acts as my fact table. So there are two things, facts and dimension. In fact table I have all the transactions, and in dimension I will have all the values stored. So here I will have geometry ID that will connect with ID of geometry, then I have material ID, then I have user ID, then I will have result A, then result B. It can be stress or deformation, anything. Now this geometry ID will have foreign key relationship between primary key ID of geometry. Similarly for material ID, mat ID, and similarly user ID will have a foreign key primary key relationship with ID of user table. So this was data normalization. So instead of inserting everything all at once, you are inserting one by one into individual tables. Suppose I have ID here, and if you are doing multiple analysis and you change any one analysis, let's say wherever one is there, so you have to change only that name. Suppose mat A has become mat A 50 grid, so you are just updating one row. And similarly all this foreign key which is linked in result table, you don't have to change all those tables. So just changing one row is sufficient. So you are saving some data as well. Similarly for geometry, in geometry ID I have 1 2 3. So suppose 2 some dimension value has changed or 1 has changed, you don't have to go to result table and change everything. Just changing one geometry is sufficient. Now once we have this conceptualization, then we have very good diagram, very good website which is called as dbdiagram.io. I use this very often. So what you have to do is, you just have to go there and type table. So let me correct it, it's table. And then in table, all you have to do is you have to type the table name. So I will use a naming convention which is table underscore geometry. And then here I will have, first column will be ID, it is an integer and it is also a primary key. And then I have for dimension A, I will type dim A, and then it will be a float. And then I will have, um, dimension B. Similarly, it is creating tables on the right side. Dimension B, it will be a float. And then I will have for all this unit, I will have one more unit table and will have unit ID here. Similarly, next will be my table material. In table material, so similarly I can just type table tbl underscore material, and under material I will have a ID which will be an integer and also a primary key. Then I will have mat mat density. I will just name it as mat dense, which will be a float. And then I will have mat youngs, which will also be a float. Then I will have mat poisons. So mat poisons. Let me so float. So let me correct this spelling. It is poisons. And then next is I will have table. Table unit. Let me and in unit I will have ID which will be an integer, also a primary key. Then I will have unit system name, mm, unit system name which will be a varchar. So let me just put 50 characters. And then I have, let's say for the unit system I will have mass, length and time. I can have, you can have whatever you want. Right now I am keeping it unit mass. It will be varchar, let's keep it 10 characters, and so on. You can add other things whatever you like. And then we have table. Then we have, what else we had users. So let's create a table tpl underscore users. And then let me rename all those. I missed to include the table naming convention. Then it will be tpl underscore users. Here I will have ID which will be an integer and also a primary key. And then I will have username which will be a varchar. Let's keep it 50 characters. And then what else we have, we can have maybe a user email which will be a varchar. Let's keep it 100 characters here. And then finally we will have this fact table which will be called as table results. So this will have ID as integer, primary key. You can see the table is created simultaneously on the right side. Then here I will have geometry ID which will be acting as a foreign key. And then I have material ID which will be integer. Then I have unit ID which will be an integer. And then I will have user ID which will also be an integer. Then finally I will have the results, maybe a result A which will be a data type float. And similarly I can have one more, result B. All these units are already taken care by unit ID. Then I have result B which is a float. And then to have this foreign key relationship, we have to use the reference. Let me add unit ID. I think material unit is not required. Yeah, and then finally you have to add reference. So there are two things. One means there are relationship like many to one and one to many relationship. For example, let me arrange this. For example, results ID, many result geometry ID can link to one geometry ID. So this is many to one relationship. So here I have to type table results dot geometry ID, which will have many to one relationship with uh, table geometry dot id. I don't know why it's not taking the link. I think there is some miss. Table geometry dot id, so it's small id, yeah, and lowercase. So you will see this connection link it has made. Similarly, it will create the ddl statement also. So let's go and create. For material ID, it will be table results dot material ID will have many to one relationship with table material dot ID. Similarly, next is we have units. For that, we can create reference table. It will be table results dot unit ID and will have many to one relationship with table units dot id. And then uh, we have users. So similarly, reference uh, table results dot user id is will have many to one relationship with table users dot id. So this is done. This is actually called as star schema. So star is our results. It acts as a fact table, and all these small geometry, material units, and users table act as a dimension table. So all you have to do is click on export. So I think I have not logged in. So once you log in, let me rearrange this. I have opened in a new browser with my logged in credential. So this was our star schema. One more is Snowflake schema. So you have to click on export. Then you have couple of RDBMS system like Postgres, MySQL, SQL Server. Right now I am clicking SQL Server. And then once this open up, you will see all the DDL statement. You have create table, table geometry. Then we have table material, then table units, table users, and the end you will also see it has created the foreign key constraint. So you don't have to worry about this. Whenever you change this, you have to just copy it and paste it in your SQL Server Management Studio, and it will automatically create the table. Similarly, if you click on MySQL or Postgres, it will change the DDL statement like few change in syntax, and it will create a table for you. Now in insert and update, this is actually DML, data manipulation language, DML syntax. In that there are two ways. So either you have five tables. In that five tables, let me change the color of the pen. Yeah, in this five tables you have two options. So in five tables, all you can do is you can do five insert queries, but this is actually not the right approach. So you should not be sending five queries to update five tables. In fact, you have to create a stored procedure. In the stored procedure, you will have all the parameters with the values, and that will go and execute the insert statement, and then it will update all the tables for you. So this is the right approach. You should not be sending five insert queries. You should use a stored procedure. So I hope you have enjoyed this video, and if you find this useful, please share and like the video. See you soon in next video.